Okay, we're going to calculate the length of BC. Now, these problems get harder because there's more than one triangle involved. So it's more likely going to be a 2 or a 3-step problem now. So in order to find BC, do you see, as you can tell, this is a 60-degree angle and this is a 50-degree angle. So this is not a right triangle, the big one, but they are split up into 2 right-angled triangles. So I'm going to put the letter D right here just so we have an additional letter so when we're talking about stuff. Does everybody know what we would have to solve first? Or do we have to solve one first over the other? Well, okay, we're going to go for the smaller triangle. We're going to solve for DC. It doesn't matter in this case. Sometimes they don't give you this height here, and they only give you this, and you have to figure out that or something like that. Then you're forced to do it in a certain order. But in this case, you don't have to. Okay, so what are we using here? Does everybody agree it's tan to find DC? Okay, so tan of 50 degrees is equal to opposite, which is DC, over adjacent, which is 8. So DC is approximately, so we're going to do 2 decimal places this time, right? 9.53. And this is centimeters. Okay, so now we're going to do BC. Does everybody see? Now we're going to do, now we're going to do BD. And what trig ratio are we going to use? Tan again. So tan of 60 degrees is equal to opposite, which is BD, divided by the adjacent, which is 8. So BD is approximately Are you going to try? No. Did you get 13.86? Okay, so therefore BC is approximately, we're going to add these two together, 23.39, and that would be centimeters, yes? Any questions there? So now we're going to calculate angle ABC. Does everybody know that that is this big angle here? So what do we have to do first? I'm going to put a D here just so that we have an extra letter there to name things. Does everybody see we need to figure out this angle and this angle and then add the two together to get the big one? Okay, how about you guys try it and then I'll go over it, okay? Okay, so let's do the first one. So this is going to be tan. I'm going to call this theta 1 and theta 2 because it's hard to name it BCD, right? So I'm going to go tan of theta 1 is equal to 3 over 5. So theta 1 would be equal to, oops, nearest 31 degrees. So this is roughly 31 degrees. And then tan theta 2 is equal to 2 over 5. Theta 2 is approximately 22 degrees. Therefore, make sure you're answering the question. If it's asking for angle ABC, you tell me what ABC is. So angle ABC equals, what is that, 53? 53 degrees. Okay, it's a little bit harder, but not really, hey? Okay, I can't read the top there. I'll have to borrow somebody's. Two office towers are 65 meters apart. The angle of depression from the top of the shorter building to the base of the taller building is 68 degrees. The angle of elevation from the same point to the top of the taller building is 22. It's saying find x and y and then find the height of the tower. Now, if you didn't know that you had to figure out x and y, would you have known that you need to figure out what this is and then add it together? Hopefully. Yeah. Okay, so I don't know why they give you so much space here, but essentially let's figure out x and y then. So 65 is this as well, because this is all rectangles here, right? So it doesn't matter if 65 is written here or up here. Y is the same as the shorter building over here. So set her up. Again, you'll notice that all these word problems are pretty much tan. Why? Because we don't care about the hypotenuse, right? Okay, I'll give you a second to figure it out. To go, right? Okay, so this is tan. So tan 22 degrees is equal to x divided by 65. So x is approximately, it said 2 decimal places, right? So tan 22 times 65. 26.26 meters. So you're getting the 1 mark for that. Then we're going to go tan of 68 degrees is equal to the opposite, which is y divided by 65 again. So y is approximately 160.88 meters. So then how the height is going to be then the two added together, right? So 160.88 plus 26.26, 187.14 meters. Okay, do we have any questions on that? Pretty easy. It's almost easier when they give you the diagram here, but at the same time, there will be questions that they do not provide a diagram and you'll have to figure it out. Okay, so let's think about this one here. How are we going to figure out angle x or length x? Say this again. Yeah, we're going to use tan to do what? To do what? Okay, so just so you know, this is not, I'm going to trace this triangle here. This is not a right triangle. You cannot use right angle trig. You know what? You don't even need to find the, well, there's a bunch of different ways you could do it, for sure. So you're saying you want to do what now? You want to find this? Okay, and then from there you're going to do what? How? This is not this blue triangle is not a right triangle. You cannot use right angle trig for it. Yes, that's okay. So this is 61 degrees. That will give you this length right here. Yes? Then you can figure out this length right here and yes, do the subtract. So you got to be careful that you don't fall into any traps where you're doing right angle trig without actually using a right angle triangle. Yes? Okay, I'll give you a second to do that. Does everybody understand what they're doing? They need to find this opposite of 61. Then they need to find the opposite of 27 degrees and then subtract to find the x. Okay, so I'm going to do tan of 61 degrees is equal to, I'm going to call this h and this y. So h over 14.3, so h is approximately 25.80. Okay, then I'm going to do, Okay, so then now tan of 27 degrees is equal to y over 14.3. So y is approximately, did you get that? 7.29. Okay, so something's wrong there. And so then x is going to be equal to 25.80 subtract 7.29, right? So it's approximately 25.8. Yeah, what's the units there? 18.51 centimeters. All right.